Junction transistor. A junction transistor is formed by sandwiching NPN or PNP semiconductor materials. This semiconductor control device was named transfer resistor or transistor. Proposed by Dr. Shockley, these junction devices operate with both holes and electrons and are accordingly known as bipolar junction transistor. In yet another group of device, control of currents by an electric field across the conduction region employing only majority current carriers. Accordingly, they are known as field effect transistors, FET, which are said to be unipolar devices. The NPN junction transistor comprises of a thin section of P-type material sandwiched between two layers of crystals, N elements. Figure illustrates the structure of NPN device. The thin P section, which has a concentration of positive current carriers, functions as the base, while the N crystals, which have large concentration of negative current carriers, they function respectively as the emitter and collector. The two N sections of NPN transistor contain number of free electrons, while the central P section possesses an excess of holes. At each junction, depletion regions develop and small potential hills appear. These are then modified by the external voltage that are applied subsequently. PNP junction transistor. The PNP junction transistor is structured with a thin section of N-type material sandwiched between two larger sections of P-type semiconductors. The N crystals have a larger concentration of positive current carriers, while the thin central lap has the concentration of free electrons. The central slab functions as the base, while the N crystals function respectively as emitter and collector. Refer figure. Biasing NPN transistor. In NPN transistor, the emitter is cut negative with respect to base, forward biased, while the collector positive with respect to base, reverse biased. In case of germanium transistor, the emitter to base forward bias voltage must be as low as 0.15 volts, while the collector to base reverse bias voltage 6 to 9 volts. Operating principle of transistor. Let us consider the operating principle of NPN transistor, since the majority current carriers in this device are negative current carriers, that are electrons. The emitter will be negatively biased with respect to base, while the collector will be made positive with respect to base. The negative potential at the emitter forces the free electrons towards the NP junction. Some of these electrons that enter the base combine with the holes in the P-base material. Because the thickness of the base and its area are relatively small, the number of electrons that combine with the holes are low. The collector to base junction is reverse biased. Such biasing attracts the free electrons in the collector material away from the junction. This action uncovers a large number of immobile positive ions in the vicinity of the junction at the collector N material. The large number of positive ions that are thus unneutralized offer very great attraction to the negative current carriers that have just entered into the base from the emitter. Therefore, a large number of negative current carriers forced from the emitter will immediately enter the collector because of the uncovered immobile positive ions. In an average, in a low current transistor, it is arranged that about 95% of the total number of electrons that are forced into the base will enter the collector. The balance of 5% of the total electrons will combine with the holes in the P material of the base and constitute a current flow in the base circuit. The nature of current carrier and the conventional current flow for both NPN and PNP transistors have been illustrated in figure. The emitter current can be designated by the symbol IE, the collector current IC, and base current by IB. In an average transistor, the collector current will be around 95% of the emitter current, and the base current will be around 5%, and the sum totaling would be IC plus IB is equal to IE. Therefore, for all practical purposes, it may be taken that the collector current IC and the emitter current IE are almost the same in a transistor. It must be noted that the collector current is mainly dictated by the emitter current and not by any other factor. Large current variation in the emitter circuit can be introduced by incorporating minute variation in the emitter base forward biased voltage. In this way, small signal voltage incorporated in the emitter to base circuit can introduce large signal voltage variation of identical wave shape at the collector circuit. In this manner, the semiconductor can act as a signal amplifier, and an average low current transistor can easily offer a signal magnification as high as 100 times. The current flow in an NPN transistor is shown in figure. The current flow in PNP transistor is shown in figure. The principle of operation of PNP junction transistor is similar to that of NPN counterpart, but the differences is the main current carriers that enter the base are holes instead of electrons. In NPN transistors, negative current carriers flow from emitter through base to collector, resulting in conventional current flow in the opposite direction. Whereas in PNP transistors, the conventional current flow is constituted by the flow of positive current carriers in the same direction. But for this difference, in all other aspects, the two types of transistors function in an identical manner.